Today, we are here to present you with the 10 ways we use AI more than we realize. Of all the interactions we have with technology in a day, interacting with artificial intelligence or not feels like a choice, but in some ways it isn't. Over the past decade, we've become surrounded by AI systems that perceive our world, that support our decisions, and that mimic our ability to create. Whether we're aware of it or not is another story. But before we begin, please make sure to like, comment, and subscribe to our channel as we strive to bring the latest and greatest from the world of AI. Number 10, recommendations. The term, the algorithm, has become ubiquitous on social media platforms like Facebook and YouTube, often carrying a negative weight. These algorithms, being an amalgam of complex rules and calculations, act as invisible gatekeepers, influencing the content users see and ultimately impacting their experience. For creators and businesses relying on social media for traffic and visibility, algorithm changes can translate to financial woes, causing dips in ad revenue and hindering their monetization efforts. So how exactly do these algorithms work? They function by analyzing a wealth of user data, including likes, shares, subscriptions, content length, and various other metrics. Based on this information, the algorithm determines which posts or videos appear in individual users' feeds. The specific workings of these algorithms are often shrouded in secrecy by the companies, partly to prevent users from manipulating them for personal gain. The lack of transparency can be particularly irksome when algorithm changes occur, leaving users in the dark about the reasons behind the sudden shifts in their social media experience. However, it's not all doom and gloom. Many platforms like Spotify, Netflix, and YouTube utilize sections like Recommend, For You, or Post We Think You'll Like. These sections also leverage algorithms in a way that allows for more excellent user agency. By comparing user activity on past posts with other users who engage with similar content, the algorithm recommends potentially exciting content for individual users. In addition, some platforms, particularly dating apps like Tinder and Bumble, allow users to accept or reject their recommendations, providing valuable feedback to the algorithm and aiding it in refining its suggestions for both the individual and the broader user base. Number 9, email filters. Email filters employ AI techniques to efficiently manage and categorize incoming emails, enhancing user experience and security. These filters utilize machine learning algorithms to analyze vast amounts of data, learning from patterns and behaviors to distinguish between legitimate emails and spam or phishing attempts. One common AI approach used in email filtering is natural language processing, which enables the system to understand the content and context of emails. Another crucial aspect of AI-powered email filtering is pattern recognition. These systems learn from historical email data to recognize typical characteristics of spam or phishing emails, such as unusual sender addresses, suspicious attachments, or deceptive subject lines. By continuously updating their knowledge base, these filters adapt to evolving threats and provide effective protection against new forms of email-based attacks. These filters also employ behavioral analysis to assess the sender's reputation and the email's legitimacy. By analyzing sender behavior and email interactions, these systems can identify anomalies and flag potentially harmful emails for further scrutiny. Number 8, autocorrect. Autocorrect is a must-have in modern typing interfaces. It leverages artificial intelligence to predict and correct spelling errors or typos made by users. At its core, autocorrect utilizes algorithms that analyze context, patterns, and probabilities to suggest or implement corrections in real time. The algorithms are composed of probabilistic language models, which employ statistical methods to predict the likelihood of certain words or sequences of words based on the surrounding text. These models take into account factors such as word frequency, language rules, and common typing errors to generate accurate suggestions. Number 7, Google Search. AI has been Google's protege for decades, let alone a few years. Every time a user types something on Google Search, he or she interacts with artificial intelligence. AI helps Google interpret the nuances of our queries, analyze the content of web pages, and even predict what we might be looking for. NLP allows AI to understand the meaning behind our words, even if they are phrased in a complex or ambiguous way. For example, if we put a query, "best pizza near me," Google's AI can use NLP to understand that we're looking for a recommendation, not just a list of pizzerias. It can then factor in our location and other preferences to provide personalized results. Number 6, personalized ads. We often find ourselves talking about something we want to buy, and the moment we open our phones, we start seeing ads about the product or service on social media. It's not magic, it's AI. Our phones constantly keep track of us. The ethical questions about this fact are a debate for another day, but what this allows for is our phones realizing what we need before we even put up a search query. Our phones serve as a gateway to allow for targeted marketing by analyzing vast amounts of our data, including demographics, interests, online and offline behaviors, places visited, and even purchase history. These insights allow advertisers to create highly targeted audiences for their campaigns, ensuring the ad reaches the most receptive users. Number 5. GPS navigation. Navigation apps like Google Maps, Apple Maps, Waze, and countless others are more than just digital maps. They're powered by the invisible hand of artificial intelligence. Gone are the days of static, pre-programmed routes. AI algorithms in these apps analyze real-time traffic data, including congestion, accidents, and construction zones, to constantly optimize our route for the fastest arrival time. They factor in the time of day, predicting traffic patterns and suggesting alternative routes to avoid rush hour gridlock. But AI doesn't stop there. It also understands different travel modes. Whether a user is driving, cycling, or walking, the app will suggest the most suitable path, keeping them off busy highways when on foot and suggesting bike-friendly lanes when cycling. This ensures a safer and more enjoyable journey for everyone. Many navigation apps also incorporate user-generated data through reporting functions. Users can flag accidents, road closures, and other unforeseen obstacles, contributing valuable real-time information to the AI system. This collective intelligence helps the app continuously learn and adapt, providing the most accurate and up-to-date directions for everyone on the road. Number 4. Phone assistants. Depending on which platform we use, we must have had Siri or Google Assistant read a web page. Unknowingly, we've used AI in all such interactions. These digital helpers on our phones, tablets, smart speakers, computers, or TVs seem rudimentary compared to something like ChatGPT, but they still analyze our voices and figure out what to do. For example, when we ask Siri to turn on our bedroom lamp, it has to understand our request and then take action accordingly. These assistants are powered by machine learning, a subfield of AI that enables them to learn and improve over time. They are trained on massive data sets of text and speech, allowing them to interpret our spoken commands and questions, even if we don't use perfect grammar or phrasing. Not only that, as they interact with more users, they learn from their mistakes and improve their ability to understand and respond accurately. Number 3. Video games. Artificial intelligence has been a part of video games since they started. When we play against a computer, the AI tells it what to do. Sometimes the AI is really good and other times less. For example, in a chess video game, the computer opponent makes moves based on studying other games. In a shooter game, enemies might react differently if we shoot, run, or hide. A classic example of early video game AI is Pac-Man. Each ghost in the game behaves differently based on preset rules, how long we've been playing, and sometimes how they relate to each other. For instance, Blinky Red chases Pac-Man. Pinky tries to move a few spaces ahead of Pac-Man. Inky moves depending on how close Blinky is to Pac-Man. And lastly, Clyde chases Pac-Man but runs away if it gets too close. Pac-Man also has a scatter mode that activates after a while. Each ghost goes into a different corner of the maze during this time. They switch between chase and scatter modes as long as we keep playing. Number 2. 3D printing. While 3D printing may not be as common as online shopping or music streaming, it boasts a dedicated user base and every single one of them interacts with AI. One of the most fundamental applications of AI in 3D printing lies in the slicing process. Before feeding a file to an FDM or fused deposition modeling printer, which extrudes plastic filament, it needs to be sliced. This crucial step involves breaking the 3D model into numerous thin layers, each representing a single horizontal slice that the printer will build upon one by one. But slicing isn't simply a mechanical process of dividing a model. AI algorithms within slicing software intelligently analyze the model to be printed and generate complex sets of instructions for the printer. For the perfect output, AI calculates the exact path the printer's nozzle needs to follow for each layer, ensuring smooth and accurate filament deposition. AI also determines the ideal amount of plastic to be extruded for each layer, balancing factors like strength, detail, and material waste. Lastly, AI identifies sections of the model that require support structures to prevent them from collapsing during printing. It then calculates the optimal placement and geometry of these supports, ensuring stability without compromising the final object's aesthetics. Number 1. Unlocking your phone. Our phones must be secure because they contain more than enough information about us that any spammer, blackmailer, or fraudster ever needs. For a million reasons, phone companies ensure that getting inside a user's phone must be as difficult as possible. To achieve that, they dialed for artificial intelligence. While a passcode doesn't embody artificial intelligence, employing a biometric security method such as a thumbprint or facial recognition to unlock phones involves AI technology. For example, Apple's Face ID employs a sophisticated process where a user initially acquaints his or her device with their facial features from various angles. Subsequently, the phone uses this data to authenticate the user's identity. Wonder where AI comes into play when we unlock our phones? This whole mechanism transcends a mere comparison of two static images. Well, these systems dynamically assess live data against stored information, factoring in variables such as lighting conditions, the orientation of the device, and other environmental nuances. It learns about changes in our facial features as time progresses and ensures that only we can access our device conveniently and securely. Subscribe to AI Symbiosis for more AI news and updates. Would you like to know how AI is the new electricity? To find out, click on the video link popping up and we will catch you there in a second. See ya!